So today I didn't really have any specific topics I wanted to talk about, but I do have the AI running, so let me get that up on the screen. And I just wanted to go over what I've been working on with the AI. As you know, with the original AI, with just the genetic, purely genetic algorithm, it was successful in figuring out the simpler equation. And so I've since tried to make improvements to that in order to upgrade the speed at which the AI would converge on the answer. And none of these have been successful with the simpler equation. Now, this does lead me to believe that this may have been a fluke that the original one got to the answer as quick as it did, but I am testing around with the idea that these improvements may not be effective on simpler tasks because and so this was something we saw when deep learning was implemented with the ball drop task. That task was so simple that the stripped down AI was actually faster at getting to an answer because it had less to worry about each individual generation. So I'm actually testing the improved AI with the more complex equation. Now, this complex equation is not the same as the one I showed you. It is relatively similar, but it is not exactly the same. So I'm going to go ahead and open up the picture of the equation here and just show you what I did. So you can see the equation on the screen now, or at least you should be able to. And what I've done is I've taken the denominator and removed it. So now just the numerator is the equation. And the reason I did this is because the answers that were that came out of this equation with the denominator included were so variable that the AI could not even try to learn. So what I mean by that is that some of the answers were less than one, but greater than zero, so they were small fractions, and some of them were to the magnitude of 10 to the power of 100 and higher. And so whenever the AI would test an equation, it would get back a least squared regression of over the size of a possible number Python is willing to use, which is somewhere over the order of 10 to the 300 power. So I had some little bits of code here and there to try and remedy that, but I decided that I shouldn't try to have that as my benchmark. I should try and do one step up from what I had previously done. So this is still a relatively complex equation. There's some constants in there which haven't been seen before. There's some power functions. There's some sinusoidal functions. So this is going to be a lot harder for the AI to figure out. Now, you can see that the AI is currently running right now, and it is 60 generations in. The score is pretty arbitrary right now because this is something that the previous running with the simpler equation that had achieved just with a completely wrong answer. So the AI can get lucky and still have that answer. So I want to look at what the equation is right now. And so on the 59th generation, it upgraded to have the equation of x variable 4 as the answer. So right now it hasn't really learned anything, but that number has gotten a little bit whittled down. And also there's some, I believe there's some variables on the deep list. Oh, okay, so there isn't. I was going to say, because there are some equations that have popped up, like there's this one that's x variable 2 plus x variable 3. And I know you can't see this right now. I don't have it up on the screen, but I'll just explain it. So the previous generation before this had x variable 2 plus x variable 3 as its second, and so there were other equations that were slightly complex that have been added in throughout this, but the actual improvement has not been seen. So this is because the score is not whittled down enough to where the AI gets desperate. Although it did just reset, so I'm not sure. I do want to let this run out to at least 100 generations just to see if it makes any improvement. But it is something that takes time because there are a lot of statistics, there are a lot of probabilities in play here, and it is possible that a particular run could go on forever, even though almost every other run would be successful. So this is something that I need to try and run more often. And I also want to go back, and I know I've been talking about this, but I want to go back and I want to rerun the initial test to see if I can replicate the results. Because that's something that's just a good practice to get in the habit of. And I want to make sure that I'm not on a wild goose chase here, and maybe I should go back to the drawing board altogether. But I don't know, we'll see. So as of right now, I have this running, and so it will be running in the background of the stream for the remainder of the stream. I want to see what I have for the improvements. So the most recent improvements that I have made is that it now kills the second parent at 10 generations as opposed to 20 generations of being stuck on the same parents. That's just something I decided would be an improvement because of the other improvement I made, which is the randomized stuck reset. So when the AI was stuck before, the AI would reset the second parent back to the original null character, the null value. And so that meant that the AI wasn't having any possibility of improvement from this reset. So what I wanted to do is just have a random chance of improvement from the reset. And so what I did is it creates a random new element which can be compound when it resets. And so that's what actually happened with that recent change, with that recent reset in the current running that we're seeing right now. Like I said, on the 58th generation, it had a variable that was compound, and I believe that is because it was following the initial variable that was put in place by the reset. So that is basically what has been going on. There were some other minor changes. I realized that my dominance score, which if you go way back to when I was talking about how the AI actually decides how variables are transferred to the next generation, the dominance score is essentially the score that is it's deciding how favored the best score is to the second best score. And it's pretty simple. It was just the best score over the best score plus the second best score, and that would give a probability. And I realized that this was not the way that it works for this individual for this individual project, because a smaller score is better. So I wanted it to favor the best score even though it was smaller. So what I did was I took that fraction and I replaced the numerator with the second best score as opposed to the best score, just so that the bigger of the two, the bigger probability was in favor of the best score. So that's a pretty simple change, but it was something that needed to be done because it was affecting the overall efficiency of the program, or at least it should have been. Also, you'll see these errors popping up. These were errors that were occurring that I just told the AI to kind of um, not necessarily ignore, but what happens is if these errors pop up, it would just say that that test was equal to the greatest possible amount of points. And the reason for that is because these errors have to do with creating answers that were complex numbers, so having imaginary numbers, and also creating equations that would receive a score that was too big for Python to handle. So this just meant that I just set it to a relatively high score so that it wouldn't even be considered, and it moved on. This saves some efficiency as opposed to trying to dig through those equations and find the small, minute piece of useful information. Also, you will notice that the mutation percentage is I'm not sure if I explained that, so I'm just going to explain it right now. So what this percentage is actually the probability that the AI will mutate at any given circumstance. So if it's looking at a particular element in the equation and it's trying to decide whether it should mutate that element, that number you're seeing is the percentage chance that it has to mutate. And so that that percentage actually goes down every time it successfully upgrades the score. And when the parent is killed, when the second parent is killed and reset, then that score doubles or goes back to 100, whichever one is lower. Because I didn't want it to go higher than 100, because then it would be stuck at essentially 100% for a very long time. And so that was the initial way it worked. It would just double, but I recently fixed that so that it would only go up to 100, which is why you're not seeing some crazy decimal. So what happens is every time that the AI successfully improves, the percentage chance of mutating is decreased by 9% of the total percentage left. So that's a percent of a percent, I know, but just imagine we had the number 81 right now. So, okay, so the previous number was 90. What is 9% of 90? That's 9. So it took the, so it took the, or you can think, what's 10% of 90? So I messed up when I was explaining it. So what's 10% of 90? Because it's saving 90% of the final answer. So if you had 100 and you subtracted 10%, you get 90. If you have 90 and you subtract 10%, you get 81, which is where we are right now. So that's how it's working. And so that 90% is just an arbitrary number. I might fiddle around with it, but the idea is that it's supposed to be something that would slowly converge to 0, but never get there. So in a case that it was close to the answer, odds are it's going to get stuck a lot and it will bump back up, but that just promotes more change so that it can figure out what that last step is. And so if the AI is improving a lot, then it has a lot more pieces to work with. And so I decided that it was important for the AI to look at the pieces that it has already and focus on organizing them in the correct orientation, as opposed to creating new pieces. This is so that it doesn't get too watered down, because if something important is created, I don't want it to lose the possibility of putting that in the right place of the equation. So this is similar to how the optimizer actually worked. It's just a little bit more dynamic as opposed to analog. So the optimizer in the ball drop program would, in the event that the AI was stuck for a long period of time, the optimizer would take a look at the if statements that were there and see if reordering them would improve the program. So this, in a sense, is the opposite logic, but the same result, or at least what I'm going for. So when the AI is not stuck, when the AI has learned a lot, then it has a lot more at its disposal that it hasn't necessarily figured out the exact spot that it needs to go. Or maybe a new deep variable is something that could be used in many different places. So what it does is, as opposed to mutating, it has now a lower chance of mutating. Now, 81% is still a pretty high chance, but that percentage continually goes down and down and down and down until it gets very small. And so there's always going to be some chance of mutating, but at the same time, the focus is put more on using its assets as efficient as possible. And so that is a pretty big change that I've made. I'm actually calling this running Datamine 3.1. 3.0 was the initial change to have this dynamic mutation factor, and but I immediately I tried it on the simple equation, and it actually got relatively close. I'm gonna pull that up just to have a reference for it. So the equation it got to was variable 3 plus the quantity of variable 2 times variable 4. So this variable 2 times variable 4 is a good piece, because the actual answer was completely multiplied by variable 4 and involved variable 2 and variable 3. So it was going along the right track, but this was at generation 162, and it actually made this improvement way back at, I'm looking for it, generation 52. So it was kind of stuck, and I couldn't really figure out what the problem was, but this is something I'm going to toy around with in the days to come. And so this obviously is going to be a long process in order to get an efficient program that actually runs smooth and fast. But I believe that I'm on the right track. So that's pretty much all I wanted to talk about today in terms of the data mining project. I don't have any other specific topics I wanted to talk about today, simply because I couldn't think of any, and I didn't want to force anything out. I just want to keep these streams relatively smooth, which is something I haven't been doing in the past. I want to work better on my transitions and whatnot. So, speaking of transitions, if there are no questions in the chat that you would like me to answer, I'm going to move on to my other section, which is my random drawing section. But if you do have any questions while I'm doing the random drawing, please leave them in the chat, and I will look at them after the drawing and possibly be able to answer them before I sign off the stream. But I'm going to give it a couple seconds so I can get things set up, and then I will move on to my next section. So bear with me. Okay, so I have a random number generator going, so I'm going to pick 3 numbers. You guys know how this works. So the first number is 17. That is a cannon. We've had that already, I believe. The first number is a foot. We will leave that to interpretation later. 21, which is fall as the verb, and 19, which is foe as the adjective or adverb. I believe that would be an adjective in this case. So a faux foot fall. And so faux being the word for fake, it is, I believe, French, just off of pronunciation. So we have a foot, but this isn't a real foot. I guess we're coming up on Halloween, so maybe this is a fake foot, and perhaps we are. Let's just stick with that Halloween theme. I know Halloween Horror Nights is just opened up, and so we will think of this as maybe a haunted house. So we can have a design for a scare, and so we will have this doorway here, and okay, so there's the door frame, the bottom of the doorway, and so people will enter the doorway in this direction, and little do they know that upon entering the doorway, perhaps there is a tripwire of sorts, but there is actually a mechanism up here with many levers and pulleys that are being used to correctly connect it to the tripwire and the apparatus that we are seeing here. But there is actually a foot that is hanging above the doorway and some small portion of the calf, but the emphasis is on the foot. So I'm going to zoom in here a little bit just for extra detail, because you have come to the place of detail, have you not? So we have our foot here, and there's a toe, and it's, so if we're going with this haunted house idea, then perhaps it's a little bit bloodied, and then the rest of it can be tan. But then we can probably clean it up a little bit, because you don't want it to be a ugly, distorted foot. You want it to be a masterpiece, because these people need to believe that it's an actual foot when it falls from the heavens or the rafters, depending on your belief system, into their welcoming arms. So, as you can obviously see now, this is a phony, bloodied foot that is being strung up by a pulley system, but for this mechanism to be efficient, there has to be some breaking point, so we can probably point that out. Break point. And so now if we zoom out, we can see that our guest, who is a stick figure today, just for efficiency, this guest is pretty happy at the moment, but little do they know that something is waiting for them just on the other side of that doorway. So I still continue my streak of unsuccessfully filling in lines, or I guess completing lines. But I believe that I was only missing that one spot today, so that's a pretty substantial improvement. I don't know, we can have, I guess we can't. Alright, so the doorway here, given in brown, is a indicator of a passage for said unsuspecting victim to enter into this haunted house. But just on the other side, we have our trap set up. So my person should not be the same color as the wall, unless they want to be. I won't judge, but I'm judging right now, I guess. So if that is a complete face, then that should be able to be colored in. So a haunted house doesn't necessarily have to be a complete two-standard building. It can just be some walls with doors, but the person will enter through the door, and On this side, they will be less happy. And also apparently somewhat red. I guess if they were truly scared, then they would be somewhat embarrassed and probably somewhat stressed out, judging by these sweat marks. So their eyebrows would probably do some sort of dance, and when you're scared, you get this big exclamation point over your head. So that's what happens according to cartoons, which you know is a relatively accurate analog to real life. So we have our phony foot being prepared to drop on a unsuspecting victim that is entering our haunted house. So this looks like a pretty complete picture. So I guess from this point on, I'm just going to answer the question I see in the chat. So my friend Thomas is asking what I thought about the refs from the UCF Maryland game. So if you don't know what happened, I am a student at UCF, and I went to the UCF Maryland game for football last night. It was, I'm going to say it wasn't the best game in general, just because we had many turnovers. The Maryland team missed 2 field goals, and nobody could really put too many points on the board. It ended up being 17-17 at the end of regulation. And so in general, the teams kind of canceled out. Obviously, they tied, but in football, you're not supposed to tie. So the college rules have a sort of shootout style overtime. So what this means is that both teams take turns starting on the 25, and they have to, just like they were in a normal portion of the game, attempt to score in the best way possible. And so let's say the first team scores a touchdown. That means that the next team has to score a touchdown in order to stay in the game. But if the first team doesn't score, or they score a field goal, and then the next team scores a touchdown, then the second team wins. And so it's a shootout style, and it goes back and forth. But what happened in the UCF Maryland game is it actually went to double overtime, which means in the first overtime shootout, we both scored touchdowns. UCF scored a touchdown after Maryland scored a touchdown, which meant that Maryland then got to choose whether they wanted to go first or second. And obviously they chose second because it's better to know what you need to achieve before, as opposed to trying to put up the most and put the person on the spot. That doesn't really work, because if someone fails to score points on their first try, on their try, then on your try, then you have less to worry about. And so it's a little bit off of your stress. But what happened in second overtime is that UCF went first, and on third down, our rookie freshman quarterback tried to throw the ball, made a very obvious forward motion, and but the ball was somewhat tipped, and it ended up going pretty much lateral. And in football, if the ball goes backwards, even on a throw, it's considered a fumble. But whatever the case was, I'm not sure what the perspective the refs had. They called it a fumble initially. And in these circumstances, anything controversial goes to a booth review. So the booth reviewed it, and because there apparently was not enough evidence to overturn the fact that it was a fumble, to say that it wasn't a fumble, which was what seemed fairly obvious in the replays, the refs considered that the call on the field stands, which means that the call was there wasn't enough evidence to overturn the call. And so I do pretty strongly disagree with how the call was handled. But at the same time, I'm not sure that it would have affected the game. I've thought about it, and so it was third down, and if the call had been given in our favor to where it was an incomplete pass, it would have been fourth down. We would have been forced to kick a field goal, which would have given us 3 points. But in the end, Maryland won with their backup quarterback, I will say, with a touchdown. So I don't think that we could have stopped Maryland. All we could have done was put up 7 points to continue playing until we inevitably failed, or just got lucky and stopped them once. So that's my honest opinion. I am pretty mad about the call, but I'm not overly distraught about the end result, I guess. So that may be the unpopular opinion at UCF, but I don't know. The whole game in general wasn't that great. It was any game that goes to double overtime is intense because when you're in the stadium, just the entire emotion is crazy. But the problem is that I tend to look at things from a practical perspective, and to be honest, I don't think in that second overtime we really had a shot, just on the fact that it went to third down and then we failed to convert that third down. Whether or not it was a fumble, I don't think it was. But the refs were wrong, but that doesn't mean that we were wrong in losing, I guess. So that's my opinion. And so if you have any comments on that, please leave them in the chat or in the comments later. But that's pretty much all I want to talk about today. I'm happy with the picture that we've created here. So I will be posting that on Facebook. And as soon as this goes live, I will also be posting the link on this to Facebook if you want to share this with any of your friends. But other than that, I plan to see you Wednesday for another midweek update. So I want to thank you guys for watching once again, and I will see you Wednesday.